So this is a National 4, National 5 lesson and the subject of atomic structure. And what we will be looking at today is electron arrangement. And what the aim is to understand how electrons are arranged in an atom or around the nucleus. The success criteria, we would want you to be able to describe how electron shells are filled up by electrons, explain how you can tell which group an element is in by its electron arrangement, and be able to draw the electron arrangement of elements in the first 20. Now, we know that in an atom, the electrons orbit, which means move around, the outside of the nucleus, and they are arranged in layers called energy levels or shells. So energy levels or shells. And you'll see both of those terms used to describe where the electrons are, but energy levels or shells. Now, when it comes to describing the electron arrangement, the rules are quite easy. And it's made even easier in the fact that the data booklet on page 6 gives you a lot of the electron arrangements for the elements. So page 6 gives you a description of the electron arrangement for most of the elements, and it definitely gives it to you for the first 20, which is what you need for National 5. Now the rules are straightforward. The first energy level can only have 2 electrons in it. The rest of the energy levels, the second, the third, and the fourth one, can contain 8. The first energy level can only contain 2 simply because it's a lot smaller than the other one. So it can only hold 2. After that, they all have 8. And whenever you're describing the electron arrangement, what you do is you write the number that are in the first energy level, then a comma, the number that are in the next energy level, a comma, number that is in the next energy level, and so on, separating them by a comma. So here's an example. An example is potassium. Potassium has atomic number 19. Now remember, in atoms, the atomic number equals the number of protons. So potassium has 19 protons. Also, in atoms, the number of protons equals the number of electrons. So we have 19 electrons as well. Now what we do is we fill each electron level as much as it can. So we fill the first one, that's 2. Then we put 8 in the second shell. That means we've put in 10 electrons so far. So we've got 9 more to put in. The third energy level can hold 8 electrons, so we'll put 8 in there. That takes us up to 18. And then the next one, the fourth energy level, well, we'll just have to put the remaining one in. So the electron arrangement is 2, 8, 8, 1. And if you look on page 6 of your data booklet, you'll see the electron arrangements for lots of atoms. Now, each shell has a maximum number that it can hold, and we've gone over this. The first shell, because it is the smallest, it can only hold 2 electrons. The second, the third, and the fourth shells, they can hold 8 electrons each. So the general rule is that they hold 8 electrons. The exception is the first shell because it's a lot smaller. Now, when it comes to filling shells, we always start from the nucleus and fill up the shells from the smallest one moving outwards. So the electrons fill the shell closest to the nucleus first, and when this is full, you move on to the next shell, and so on, and so on. So you can see we put 2 electrons in the first shell, then 8, and then we keep going. So you fill the first shell first, the second shell second, the third shell third, etc. Now, what's really important and what gives atoms their special chemical properties is the outer shell. And the outer shell is the last shell that has an electron in it for an atom. So for some atoms, this might be the first shell. For other atoms, this might be the fifth shell. But it is the last shell in which there is an electron. And it's called the outer shell, sometimes called the valence shell. But if we remember it as the outer shell. However many electrons there are in the outer shell tells you the group number. And if you have access to page 6 of the data booklet, what you can see is that if you look down group 1, all of the electron arrangements end in the number 1. If you look down group 2, all of the electron arrangements end in a 2. For group 3, they end in a 3. For group 4, they end in a 4. That last number in the electron arrangement is the number of electrons in the outer shell. So for this one, what group does it belong to? Well, the nucleus is the inner circle, which has got a plus and then a black circle, and the black circle is a neutron. And we see it's only got one shell and there's one electron in it. So it's got one shell in its outermost shell, so it is group 1. What about this atom? Have a go. Remember that the number of electrons in the outer shell is equal to the group number. So what group does this atom belong to? Well, that atom belongs to group number 6 because it has 6 electrons in the outer shell. Now, we've got 3 questions to finish off, 4 questions actually, but I want you to have a go at drawing some atoms. So you're going to draw just a black circle to represent the nucleus, and all we want to see is the electron shells, and then you to put in the electrons. So you can draw small circles to represent the electrons, or if you like, you can draw the electrons as an X. Both are acceptable. So what you're going to need to do is look up the element, find out how many electrons it has, or you can look up page 6 and look directly for its electron arrangement, work out its electron arrangement, and then draw the atom. So the first one is neon. So if you pause the video, have a go, draw the circle, and I'll reveal the answer. So make sure you've got a data booklet so you can look up the number of electrons or the electron arrangement. Have a go at drawing the nucleus and then the electron shells for neon, putting in the different electrons. So hopefully you've unpaused the video now, had a go at that, and this is what neon should look like. So neon has the electron arrangement 2, 8. 2 electrons in the first shell, 8 electrons in the second shell. The next example, the next question is magnesium. So again, pause the video, have a look for magnesium in the data booklet, and then have a go at drawing its structure. When you unpause the video, I'll show you it. So your answer, your atom should have looked like this. 2, 8, 2. So 2 in the first shell, 8 in the second shell, and then you need to go into the third shell to put 2 electrons. And because it's got 2 electrons in its outermost shell, that means it's in group 2. And finally, we've got nitrogen. So again, I want you to draw an atom of nitrogen. So pause the video, and whenever you come back, hopefully it'll match your diagram. So nitrogen looks like this. It is 2, 5. So 2 electrons in the first shell and 5 in the second shell. Because it's got 5 in its outermost shell, that means it's in group 5. Now what we've got here is an example of a question that you might get in an exam. It's a multiple choice question. Now here we have tennessine, the newly discovered element with a predicted electron arrangement of 2, 8, 18, 32, 32, 18, 7. Which group of the periodic table should it be placed? So, which is the correct answer? Well, with this, remember, the number of electrons in the outermost shell tells you the group, and tennessine's electron arrangement ends in a 7, so it must be in group 7. So C was the answer. So you should probably now be able to describe how electron shells are filled up, be able to tell which group an element is in by its electron arrangement. Remember, the number of electrons in the outer shell is the group that it's in. And you should be able to draw the electron arrangement of the first 20 elements. Thank you for your attention. Hopefully you participated in drawing out those atoms, and I will catch you next time.